Okay, that's good. Let's go ahead and get started on this and make sure we're all on the same page. So, pretty easy decimal approximation here. In fact, that's not an approximation. That one's going to be exact. What if you take radical 2, which is about 1.414, and divide it by 2? About 0.7. Okay. And what about radical 3 over 2? So about 1.7 divided by 2. So would you say about 0.9? If we round to the nearest tenth, so that's going to be 0.9. So now remember, we're talking about the y-coordinate. Remember, the y-coordinate starts off at 0, and then it gradually gets bigger. So we go from 0, what's this one? 0.5, 0.7. So we've covered half the angle up to 90 degrees, and we're already at 0.7. This one's 0.9. We're at 60 degrees. The y-coordinate is 0.9. And then we cover these last 30 degrees, and it only goes from 0.9 to 1, right? And then what happens to the y-coordinate? Gets smaller. So we go to 0.9, 0.7, 0.5. In between 30, reference angle of 30, in between 150 degrees and 180 degrees, it goes from 0.5 to 0. And then what happens down here? Same exact thing, it's just negative, right? So this would be negative 0.5, negative 0.7, negative 0.9. Negative 1 is the y-coordinate there. Negative 0.9, negative 0.7, negative 0.5, and then we're all the way around full circle. So if we wanted to go through and label these in degrees or radians, that'd be fine. I said label them in radians. What do you know? I should follow my own instructions. So this is 0. This is going to be pi 6, pi fourths, pi thirds, pi halves. We're pretty good at this point right now. 2 pi thirds, 3 pi fourths, 5 pi sixths, pi, 7 pi sixths. What do we got here? 5 pi fourths. This is going to be 4 pi thirds, 3 pi halves. Let's see, 5 pi thirds, 7 pi fourths, and the last one here is 11 pi sixths, right? Go all the way around the full circle, you got 2 pi. Any questions there? Maybe moderately interesting, but probably not, because we haven't gotten to the point yet. The point in this section is what we're going to be doing is we're going to be using the values on the unit circle to come up with graphs of the trig functions. The two that we're going to start with today are the sine and cosine functions. So if you've seen this before, that's fine. Make sure you've got all the details down and that sort of thing. The point is with this is if you're given some complicated expression or some complicated equation to graph, you can do it by plotting points. So if I gave you something ugly like this, and let's say I picked Greg back there who's eating his lunch, and I said, Greg, I'll give you $1,000 if you can come up with an accurate graph of this in an hour. Think he'd do it? Yeah, he'd pick a whole bunch of points. He'd start off with what you learned to do when you learned how to graph. You make a little XY table, you pick a bunch of these. The more complicated the graph is, the more points you have to pick. But you could come up with roughly what it looks like, okay? You may have to pick a lot of points, but you can come up with a pretty decent sketch, okay? So if we were given this equation right here to graph, y equals the sine of theta, okay? Well, this is y in terms of theta, not y in terms of x. So we could make a theta y table, so we just change this to theta, or we could just change the variable and say, you know what? I'm going to let x represent the angle that I plug in. So x is not going to be an x coordinate now, it's going to be the angle that I'm plugging into the sine function. Okay, so little adjustment there. So that's what we're going to do. We're going to graph y equals the sine of x, and we're just going to plug in some numbers. We're going to figure out what it looks like. So I'm going to plug in 0 radians, I'm going to plug in pi sixths radians, pi fourths radians, pi thirds, and pi halves. So if I do that, I've actually got the values of the sine of 0, the sine of pi sixths, the sine of pi fourths, and so forth sitting right here. What is the sine of 0? It's the y-coordinate at 0, so that would be 0. That's the point we need to graph. If I do pi 6, sine of pi 6 is 0.5. If I plug in the sine of pi fourths is right here. We want the y-coordinate, so that's going to be 0.7. Now, we could have done this exactly. This would be 1/2. This would be radical 2 over 2. The next one would have been radical 3 over 2, but we're going to write it down as what decimal? 0.9. And then the next one at pi halves, it's 1, right? Okay. Hang on 1 second. Okay, so let's graph these. This goes from -1 on the y-axis to +1 on the y-axis. I've marked this out already. I'm going to mark the end of this. This is 2 pi here. I've got a couple little hatch marks here, so this is going to be pi. Half of pi right in the middle here would be pi halves. And this would be right in between pi and 2 pi, so this is going to be 3 pi halves. Now I'm going to put the labels down here just to kind of keep them out of the way of what we're going to graph. And then let's go ahead and plot these points. So this is 0, 0, so I'm going to put a point right there. Okay, now the next easiest one to graph probably would be this one right here. So let's put pi halves comma 1 on there. So if I put pi halves comma 1, that would be right here. Now it doesn't go straight from here to here. Let's graph this one. You're going to find that eyeballing like the midpoint of 2 other points is going to be really helpful. So pi fourths is right in between the 2 of these. So pi fourths is about right there. I'll just put a little mark. And then I need to go up to 0.7. So 0.7 to me looks like it's about right there. Pi 6. Now pi 6 is 30 degrees, right? If this is the equivalent of 0 and that's the equivalent of 90, 30 would be about right here. And I'm going to go up and I'm going to graph a point of 0.5. Function value right there is going to be 0.5. And then at 60 degrees, or at pi thirds, so about right there, function value is 0.9. So I'm going to go up here and I'm going to put 0.9, so really close to 1 right there. Okay, are there any questions on anything we've done here? Okay, does it look like a line? I don't think so. Okay, a line would go straight from here to there. Okay, it's a little bit higher than this, and it's curved. So the graph looks something like this. Comes up here, hits this point, kind of levels off, looks something like that. Okay, is everybody listening? Because this is going to pay off in this chapter, and it's going to pay off probably about chapter 6. Okay, these were all angles in the first quadrant, right? From 0 to pi halves, all in the first quadrant. Let's come back up here and let's take a look at what happens to the y values that we're going to graph in the second quadrant. They started at 0 and got really big, got up to 1. In the second quadrant, they start at 1, and what happens to them? They go right back down to 0. So I could take the time to erase this or make another XY chart. Or I could just say, you know what, the same thing happens on the way down. In fact, if I plug in change this to an X. If I plug in pi, what's the y coordinate at pi? 0. So I'm right back down where I started. So I'm going to graph this one right here. At 135 degrees, or at 3 pi fourths, have a function value of 0.7. So the graph goes up in this fashion, and then it comes down in exactly the same fashion. It goes like that. Okay, I'm going to pick a couple other easy points to graph. Let's say I did 3 pi halves, and then let's say I did 2 pi. What's the y value at 3 pi halves? It's right down here. It's -1. That's the one that we plotted over there. So I'm going to graph 3 pi halves, which was right here, and -1. So I'm going to follow that over there so it looks about right. There we go. And what is the sine of 2 pi? What's the y-coordinate at 2 pi? Once we've gone all the way around the circle, it's going to be 0 again. So that's going to put me right here. Now remember what we said about these y-coordinates. They start at 0, go down to -1, and then start going back up. And they hit the same numbers. So this one right here, which would be 5 pi fourths, is going to be -0.7. This one, that's 7 pi fourths, would be -0.7. So it goes up, makes this curve on the way up, and on the way down does this. Okay. Are there any questions? Okay, this shape right here, it's the pattern and the shape that's made by the sine function. So if we were to plot out the ratios that come out of the sine function, this is what they look like as we go around the circle. Okay? Now, is there any reason why we had to start at 0? And any reason why we had to stop at 2 pi? No, we could plug in angles that are bigger and smaller than those. We could plug in negative angles. So to emphasize that, I'm going to put an arrow on the end of this and say it continues in that direction, and put an arrow on this and say it continues in this direction. So if we were to graph the whole thing, which would just keep going on forever, it would look something like this. Okay? It would just be a graph that goes up and down over and over again, repeating that pattern. Okay, are there any questions? Sure? Okay, now we're going to do a little bit of this. I'm going to change colors. We're going to do a little bit of this, not a bunch. What if we kept track of the x-coordinates now? The y-coordinates, that's what the sine does. If we did sorry, did I say y-coordinate's what the sine does? X-coordinate is what the cosine does, right? So what's the x-coordinate right here? It's 1. What would the decimal equivalent be? Remember, it would be the long side on a 30, 60, 90. That would be radical 3/2, so this is 0.9. These are both the same, so that's 0.7. This would be 0.5, and this would be 0. So the cosine is going to start at 1, and it's going to get smaller. And what happens to these x-coordinates here? Okay, they're negative, and they get bigger as we go along. So this is going to be -0.5, -0.7, -0.9, and -1. Then it's going to repeat the same pattern over here. Everybody good? Okay, so you've got the advantage of seeing the whole thing all at once. I'm going to come down here, and if we were to make a chart for this, this would be x and this would be y. If I were to plug in 0 and maybe plug in pi fourths, plug in pi halves, and so forth, what's the cosine of 0? The x-coordinate 0 is 1. What's the cosine of pi fourths? 0.7. At pi halves, it's 0. So it goes something like this. In the first quadrant, it starts out at 1 and then gradually gets smaller. Kind of drops off pretty quickly after we get past 45. What about at 3 pi fourths? Let's come back up here and take a look. What is the cosine of 3 pi fourths? It's -0.7. So that would be about right here. And at pi, what's the x-coordinate of pi? And then we need to look at this. The x-coordinate at pi is -1. So the cosine of pi is -1. So that means the graph does something like this. And what do you suppose it does over here? Does the same thing, except for they start at -1 and they get bigger. They get closer to 0. So we have a graph that looks something like this. And then it's going to end up at 1. It's going to look like that. So cosine starts at 1, goes down and hits 0, goes down and hits -1, back up to 0, and then back up here by the time we go all the way around the circle. Again, this is 0, this is 2 pi, and this is pi, which makes this point right here pi halves, and makes this point right here 3 pi halves. Any reason we'd need to stop? Nope, that pattern would just continue. It would continue making that shape. But that's one basic cycle. That's one basic pattern. And we're going to talk about what we call those. So, are there any questions on anything that we've done here? This is the shape and pattern made by the sine function. This is the shape and pattern made by the cosine function. So everybody understand? Can you see where they come from? No questions? All right, then let's take a look at the next page. We've got some vocabulary that we need to fill in. Okay, this is a cyclic, is how we say this, or a periodic function. And that's simply a graph that repeats the same shape. Over and over and over. So that's a cyclic or a periodic function. Okay, then let's talk about the next word. This is kind of a funky word. This is what's called a sinusoidal curve. A sinusoidal curve. That's a fancy name for a wave function. Both of these graphs up here are both sinusoidal curves. That's the sine function, that's the cosine function. They're both sinusoidal curves. Okay, let's talk about what the period is. Okay, the period is the horizontal distance needed to repeat the shape of the graph. So, horizontal distance needed to repeat the shape or the pattern. Okay, horizontal distance. Because it's a distance, distance is always positive. Okay? Next thing is the amplitude. There are two ways to figure this out. It is the distance from, we'll call it the midline. You can call it the center line if you want, to the top or bottom. Okay? We could call those a peak or a trough. Okay. It's also half the distance from the very top to the very bottom. Either way you want to think of it is fine. Okay. Since the midline's right in the center, that would take into account it's half the distance from the top to the bottom. Okay. And then we're going to say this all the time. So I'm going to say graph one cycle and make sure you label 5 key points. Okay. So we're going to graph the beginning, the middle, the end, and the quarters. So if I say graph 5 key points, that means you're going to graph the beginning, the middle, the end, and the quarters. So let me show you what the 5 key points are here. So everybody got this written down? Okay, so here are the 5 key points on these two functions. The 5 key points on this one are right here, up here, 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 and here. There's the beginning, there's the middle, there's the end, and these are the quarters. This is 1/4 of the way through the whole cycle, and this is 3/4 of the way through the whole cycle. So this one would be 0, 0. This one would be pi halves, comma, 1. This one would be pi, comma, 0. This one would be 3 pi halves, comma, -1. And this one would be 2 pi, comma, 0. Okay, would you label the 5 key points on this one? So there are the 5 key points for the sine function. Label the 5 key points for the cosine function. So the x-coordinate here is 0, the y-coordinate's 1, so it starts at 0, 1. And then this point is pi halves, comma 0. This point right here is pi, comma negative 1. This one is 3 pi halves, comma 0. And this one is 2 pi, comma 1. 5 key points on the cosine graph, 5 key points on the sine graph. They look very, very similar. The big difference is the sine starts at 0 and goes up to 1, and the cosine starts at 1 and goes down to 0. Okay? That's how you can tell them apart. Any questions? Sure? Okay. Let's take a look at something that you should be really familiar with. Let's take a look at that one right there. And can you tell me what that 3 does to this graph? Okay, up 3. We call that a vertical shift. Can somebody tell me what that 1 does to the graph? Okay, moves it 1. Which way? Moves it to the left. Okay, so we're going to go left 1. It's a horizontal shift. We're going to have a fancy name for that in just a second. But that's a horizontal shift. Remember, anything inside the parentheses before the function makes the shape does the opposite of what you'd think. So you would think it would move it to the right one. It doesn't. It moves it to the left one. Okay, and there's a good reason why it does what it does. Okay, what about the 2? Okay, careful. Just the 2. Okay, it's a vertical stretch. It makes it steeper. Okay, it's a vertical stretch. It makes it steeper. So I'm going to put vertical stretch. Okay, and what does the negative do? Okay, that's a vertical flip. Flips it across the x-axis, right? So if you know what these things do with a parabola, a very familiar function, the interesting thing is what you learned in Math 1010 or Math 1050 or wherever you learned it, those transformations do the same thing regardless of the type of function that you're working with. So we've got this new function, a couple of new functions, a sine graph and a cosine graph. If you know what they did to the parabola, they do the exact same thing here. So what do you think the 2 does to the cosine graph? Okay, what type of stretch? It's a vertical stretch. So again, let's be careful about this. I've got some graph paper on the website that just has a set of coordinate axes. If you want to use your own paper, that's fine. Regular graph paper is kind of tough because you have to look at what the scale would have to be and figure that out. So here's what we're going to do. We're going to graph the beginning, the middle, and the end. So I like doing this. Everybody watch, please. I like marking the end, and I'm going to say this is going to be 0, and I know it completes one cycle, or it's one period of 2 pi. Then I'm going to eyeball where the middle is, and then I'm going to eyeball the quarters. So it looks like that. So again, sticking with that whole idea of we're going to graph the beginning, the middle, the ends, mark the beginning, mark the end, eyeball the middle, and then from that eyeball the quarters. Those are where our 5 key points are going to be. Now, cosine. Cosine starts where? At 1 or at 0? Starts at 1. But what does this 2 do to that 1, that function value? Makes it twice as big, so it makes it up here at 2. The next key point I'd graph would be at pi, comma 0. What happens if you stretch a 0? You still get 0. So there's our key point right there. And at pi, it would normally have a function value of -1. It's going to have a function value of -2. And then it's going to do the same thing on the way back up. So here's what the graph looks like. I've got those 5 key points. It's going to look something like this. And just keep doing that over and over and over again. I'm going to put some arrows on here. I've got my 5 key points. Maybe this isn't perfectly to scale. Any questions? Okay, everybody watch, please. I'm going to label this point. This point is 0 for an x-coordinate, 2 for a y-coordinate. This point right here, pi halves, comma 0. This point right here, pi comma negative 2. This one would be 3 pi halves comma 0, and this one's going to be 2 pi comma 2. Any questions there? Okay, you don't need to do this, I just want you to watch. If we graphed on this same set of axes, the original, the parent graph of the cosine, it would have started at 1, gone through 0, hit negative 1, hit 0 again, and then hit positive 1. So it would have looked something like this. Can you see the vertical stretch there? Did it make all the points twice as tall as they used to be? Twice as far from the x-axis as they used to be? Okay. Any questions there? Sure? Okay, I'm going to slide this down. Let's take a look at the next one. We've got a couple things going on here. Let's see. We've got this thing right there, and we've got this. What does the 2 do again? Okay, that's going to be a vertical stretch. It's going to make the points twice as tall as they used to be. What's the minus pi fourths going to do? Okay, this is going to shift it to the right pi fourths. So we're actually going to move it to the right pi fourths. Okay, everybody watch, please. Okay, it's going to take this shape, that red shape right there, and it's going to take all of the points and it's going to move them to the right, pi fourths. Now, since we've already got this one up here, I'm going to take advantage of that. Okay? And the fact that I picked this to be a fairly nice problem, let's mark where pi fourths is going to be. Because one of the hardest things to do here is to keep straight, all right, what if I move this fraction pi fourths, or what if I move pi thirds or something like that? Let's mark where that would be. Here are intervals of pi fourths there. So if I were to move this to the right pi fourths, that would move this one right here. This one would move right here. This one would move here, here, and here. What points did I just mark off? What do we call them? Those are the 5 key points on this new graph. So this new graph looks something like this. Goes like that, comes down here, hits this one, hits that one, comes up and hits this one. Now my question for you is, can you label each of those points? Probably. It's not too hard, is it? Where's this one? Pi fourths, because we moved it over pi fourths. So if all you're doing is sliding it to the right, what's the only coordinate that changes? It's only the x-coordinate that changes. So this is going to be pi fourths comma 2. Okay, now, if I take pi halves and I move it over pi fourths, what do I get? 3 pi fourths. 3 pi fourths comma 0. If I go over pi fourths from, let's see, that's pi, so that's going to be 4 pi fourths plus another pi, so that's going to be 5 pi fourths. These are looking familiar, aren't they? This one would be 7 pi fourths comma 0, and what's this one? You've got 2 pi, we're going to slide that over a pi fourth, so that's going to be 2 pi fourths is 8 pi fourths plus another pi fourths is going to be 9 pi fourths comma 2. Again, take a look at this one and look at the original, that blue dotted graph right here. Does the green one look like it's been vertically stretched and then slid over pi fourths units to the right? Okay, all right. I know some of you know what this is called. We don't call this a horizontal shift. Does anybody know what we call these in trigonometry? Okay, we didn't just do a horizontal shift, it has a name. Okay, it's called a phase shift. Because we're shifting the phasing or the cycling of that trig function by pi fourths. Okay, now, we actually did something on this problem without realizing it. If you graphed it up here, that makes it a little bit easier. Most people find it easier, Okay, if you want to make sure you're getting the right shape, it's generally easier to make the right shape and then move it where you want. Okay, it's kind of hard to say, okay, I need to stretch this point and then move it over. If you can do that, that's fine. But most people find it easier to make the correct shape and then slide it left, right, up, down, whatever you need to do. Okay? Are there any questions? Okay, let's take a look at the next one. Okay, you want to memorize the 5 key points on the sine graph and on the cosine graph so that you can stretch them, shrink them, slide them left, right, up, down, all that sort of stuff that we're going to be doing over the next couple of sections. So let's take a look at this one right here, and then let's figure out what goes on here. We already know what the 2 does. That's going to be a vertical stretch. This is going to be a phase shift. We're going to move it to the right, pi fourths. So I'm going to write P period S period equals positive pi fourths. That tells me my phase shift is going to be positive pi fourths. I'm going to move it to the right pi fourths. And there's no fancy name for this. This is just a vertical shift. I'll just write that there. But basically, we're on this problem, we're going to go down 1 unit. So let's pretend we didn't have that stuff up above. Okay, you've got it, you can look at it. Okay, but let's say this is the problem we're given, and we've got to come up with a decent sketch, and we've got to label 5 key points on it. Okay, what I would do, if I wanted to make sure I got it right, I'm going to make the correct shape. So I'm going to mark the beginning, the middle, and the end. So I've got this here, and you can label them if you want. Okay, I usually just like labeling the beginning and the end. If you want to label the middle and the quarters, that's fine with me. And I'm going to set my scale, keeping in mind that I need to slide this all down 1 unit. So I'm going to go like this. There's 1, 2, 3, 1, 2, 3. So I'm going to scale things out so that it looks about right from the beginning. Does my scale up here look like my scale down here? Okay. The more careful you are in setting things up, the better off you're going to be. Okay, so let's make the right shape. The right shape looks like this. It starts at 1, stretched, so that would be at 2. Then it hits 0, then it hits -2, then it hits 0, and then it hits 2 again. Okay, so this is the right shape. Doesn't take too long to mark things out. They're at nice even intervals. That is the correct shape. What's wrong with that red dotted graph that I've got up there? It's not in the right place. So I need to do 2 things with it. I need to take all those points and I need to move them to the right pi fourths, which is going to change which coordinate? The x coordinate. And I need to slide them down 1 unit, which is going to change the y coordinate. So to graph the final answer, this is what I'm going to do. I'm going to take that point and slide it over pi fourths, which is nice that I've marked this off because I know if this is pi halves, pi fourths is about right there. I need to go over pi fourths and down 1 unit right there. Now you'll notice that it looks like I went over 1 and down 1. That's why scaling is so important. Notice this is in terms of pi. This is 1, 2, 3, 4, and so forth. Okay? I need to go over pi fourths and down 1, over pi fourths and down 1, over pi fourths and down 1, over pi fourths and down 1. Now, take a good look at those blue dots I've got up there. Do they look like a cosine graph? Do they look like a sinusoidal function? Hopefully. Okay, let's go ahead and sketch what this would look like. It's going to look something like this and this. That's crappy. We're going to have to do that again. It's sometimes helpful to label the center line, label the midline. The midline on this one goes through right here. What's the equation of that line? That's y equals -1. Why is it at -1? Yeah, because we took the old midline and slid it down 1 unit. Okay. I'd like you to label those 5 key points. Make them nice and big. If you have to label where the original one was, that's fine. This is our first one where we've done a vertical stretch, a phase shift, and a vertical shift. So if you need to look at the previous one, no problem there. That point right there is at pi fourths, comma, where is it? It's at 1. This one right here is at 3 pi fourths, comma, negative 1. And this one is, well, let's see, we were at pi, we moved it over. So this is going to be 5 pi fourths, comma, we're all the way down at negative 3. And this one is going to have the same y coordinate, so that's going to be negative 1. That's 7 pi fourths. And then this one's going to be 9 pi fourths. It'll have the same y coordinate as this one right here, so it'd be 9 pi fourths, comma 1. Okay. Any questions? Sure? Okay. There's a vocabulary word that we haven't used a lot. We described what it is, but we haven't used it on this. A couple of them, actually. Okay. What's the period? What's the horizontal distance needed to repeat this pattern? It's 2 pi. The period on both of those is 2 pi, for sine and for cosine. Takes 2 pi to repeat that shape. What's the amplitude here? What's the distance from the midline up to a top or a bottom? Or what's the difference between 1 and negative 1, and then we take half of that? What's our amplitude here? Amplitude on both of these is 1. So these both have a period of 2 pi. They both have an amplitude of 1. Let's take a look at this next page. Once I throw that 2 in front, what did it change? Okay. The amplitude on this one is 2. Remember, it's a distance. Both of these are going to be positive numbers because they're distances. This is the horizontal distance needed to repeat the pattern. This is just the difference from the midline up to a top or a bottom, to a peak or a trough. Any questions there? Okay. All right, let's take a look at, you don't have this. This is actually a page out of your book. Okay. This is page 122. You do have several problems like this. We've gone over a bunch of ideas that are going to be helpful for the homework, and they're going to be helpful in the next section that we're going to cover on Monday. So it says, find the coordinates of each given point after it's been moved pi fourth units to the right. If it moves to the right, which coordinate changes? X. All you have to do on this one is, this would be pi fourths, comma 0. Where would this one be? That would be at pi, comma negative 1. All you have to do is move it to the right, change the x coordinate by adding pi fourths. This one says find the coordinates of each given point after it's moved pi 6 units to the right. A little tougher to work with pi 6 than it is to work with pi fourths, and 2 units upward. This is going to change the x coordinate. This is going to change the y coordinate. So if I take this one and I move it pi 6 to the right, pi 6 to the right, I'd add pi 6. Right now this is 6 pi 6. See why you got to be good at working with fractions? This is going to be 7 pi 6, comma. If I move this up 2, if I'm at negative 1 and I add 2, this is going to be 7 pi 6, comma 1. That's the answer to that problem right there. Okay? Would you do this one? Do number 30, please. If you can do that one, you're in good shape on like the first 30 problems. It's those stinking fractions again. I have to take pi thirds and I have to add pi sixths. So I've got to get a common denominator. Right now, pi thirds would be 2 pi sixths. Add another pi sixths. What's the surprising x coordinate? Pi halves. Thank you very much. So pi halves, and then we're going to move this up 2 units, so that's going to give me positive 1. There's the answer on that one. Any questions? Okay, let's take a quick look at a few of these. This one says, determine the point that lies midway between the 2 given points. Smack dab in the middle. You could go to the trouble of using the midpoint formula, which is like the average point formula, how you average 2 points. You add the 2 points together and you divide by 2. Or you can just look at this and say, look, if I'm here at pi, which is where that point is, and I'm over here at 2 pi, which is where that point is, right smack dab in the middle, they'd have the same y coordinate, right? So it's going to have 0 for a y coordinate. What's in the middle of pi and 2 pi? 1.5 pi or 3 pi halves, okay? Literally that simple. Okay, are there any questions there? But notice, look what they're having you average. They're having you average x coordinates that are in terms of pi just to get you used to that. Okay, any questions there? Easy enough so far? Okay, so this says determine the coordinates of P, Q, R, and S on each sine curve. So you have to look at this, look at the way things are scaled, and figure out where are these. Okay, that one's a piece of cake. 0, 0. If this is pi, see why I said it's good to be able to figure out where the end, the middle, and the quarters are? If that's pi, where's the middle? Pi halves. Where would the quarters be then? This would be at pi fourths, and this would be at 3 pi fourths. And this would be down at -2. And this would be at 0, so this is going to be pi halves, comma 0. And this is going to be at pi fourths, comma 2. Does that make sense? Okay. All right. The main thing I want you to be able to do is to be able to know that basic shape, know the 5 key points of the fundamental sine curve and the fundamental cosine curve. Okay? And let's take a quick look at this one. This is number 75. It says it's a sine curve. And it says write an equation of this form where you've got an amplitude change, you've got a phase shift, and then you've got a vertical shift. There's not one single answer to either of these problems. Okay? But I will give you a hint, and you need to think about this because you have one of these on your assignment. Okay, does sine, does it start at 0 and go up, or start at 1 and go down? 0. Start at 0 and go up. So probably the easiest way to do one of these is to find the midline, which is pretty easy to find, and find where the cycle starts and goes up, and think of it in terms of that. Okay? If that's the case, can you look at it and tell what the amplitude is, how much it was vertically stretched? Yep. Can you look at it and tell whether it was moved left or right? So you can figure out the phase shift. Remember, it's the opposite of what you'd think it would be. And was it slid up or down? Not this one, but this one was. Okay? Please get those memorized. You really need to know those shapes well. If you have 2.1 done on Monday, you're going to be in great shape for 2.2. Okay? Have a great weekend.